The universe is far stranger, more vast, and more astonishing than most of us ever imagine. For centuries, humanity looked up at the night sky and saw little more than distant points of light, fixed and unreachable. Today, that illusion is gone. With modern telescopes, robotic explorers, and deep space missions, we are finally beginning to see the universe as it truly is, a place filled with environments so extreme, so alien, that they barely feel real. In this journey, we are not chasing science fiction. We are exploring real locations that exist right now, scattered across the cosmos, places that challenge our intuition and stretch the limits of what matter, energy, and time can become. Our story begins close to home, on a world that humans have dreamed about for thousands of years. Mars, the red planet, has long captured the imagination as a possible second Earth. Yet the more we study it, the more surreal it becomes. Mars is not simply a cold desert planet. Its surface is carved by vast canyons that dwarf anything on Earth, and its landscape still carries scars of a time when liquid water once flowed freely. Today, Mars is a world of thin air, freezing temperatures, and relentless radiation. Robotic explorers crawl slowly across its soil, drilling into ancient rock layers, searching for chemical traces that hint at a warmer, wetter past. The irony is striking. Mars looks familiar, yet it is utterly hostile, a reminder that appearances in the universe can be deeply misleading. Beyond Mars, the solar system reveals places that feel even less real. Consider Jupiter, a giant world that blurs the line between planet and star. Beneath its colorful cloud bands lies an ocean of liquid hydrogen so compressed that it behaves like metal. Lightning storms rage endlessly in its atmosphere, each one far more powerful than anything on Earth. Jupiter's gravity shapes the entire solar system, deflecting comets and influencing the orbits of countless objects. It is not a solid place you could ever stand upon. It is a vast, churning sphere of pressure and energy, a reminder that planets do not need solid ground to dominate their surroundings. Orbiting Jupiter are moons that seem pulled from different realities. One is a volcanic nightmare, its surface constantly reshaped by eruptions that pour molten rock into space. Another hides a global ocean beneath a frozen crust, where liquid water may be kept warm by tidal forces alone. These moons exist because gravity itself can act as a source of heat, flexing worlds like cosmic stress balls. In these places, geology does not depend on sunlight. It depends on motion, on gravity, on relentless orbital dance. As we move farther outward, the familiar structure of planets and moons gives way to stranger forms. Saturn's rings, thin yet vast, stretch across distances that make Earth seem microscopic by comparison. They are made of countless icy fragments, each one following its own orbit in perfect balance. From a distance, the rings look solid and serene. Up close, they are chaotic, dynamic, and constantly changing. They exist in a fragile state, neither fully forming into a moon nor collapsing into the planet. It is a cosmic balancing act frozen in time. Leaving the solar system entirely, we enter the realm of stars. Here, reality grows even more extreme. Some stars burn calmly for billions of years, while others live fast and die violently. There are stars so dense that a single spoonful of their material would outweigh entire mountains. Their gravity is so intense that atoms themselves are crushed into unfamiliar forms. These stellar remnants spin at incredible speeds, sweeping beams of radiation across space like lighthouse signals. From Earth, they appear as steady pulses, precise enough to rival atomic clocks, even though they are powered by collapsed stellar cores. Among the most breathtaking sights in the universe are nebulae, vast clouds of gas and dust where stars are born and destroyed. From a distance, they look like soft, glowing paintings. In reality, they are immense regions shaped by radiation, shock waves, and gravity. Inside them, new stars ignite, carving cavities and pillars out of the surrounding material. These structures can stretch for light years, towering over anything the human mind can easily comprehend. They are not static clouds. They are dynamic environments, constantly evolving over millions of years. As our journey continues, one truth becomes increasingly clear. The universe is not built for comfort or familiarity. It is built for extremes. Heat, cold, pressure, and energy reach levels that defy everyday experience. Worlds exist without solid surfaces. Oceans hide beneath ice. Stars collapse into objects smaller than cities, yet heavier than suns. Each new place forces us to revise our assumptions about what is possible. This is only the beginning of our exploration. We have not yet reached the darkest depths of space or the most mysterious phenomena known to physics. For now, we stand at the threshold, having glimpsed just how unreal real places in the universe can be. And as we continue, the strange will only grow stranger. As we push deeper into the cosmos, the sense of scale begins to shift in unsettling ways. Distances stretch beyond ordinary intuition, and familiar reference points dissolve. Stars no longer feel like distant suns scattered gently through space. They become markers in a vast ocean, separated by gulfs so large that light itself takes years to cross them. In this domain, even emptiness carries weight, and the silence between objects is as meaningful as the objects themselves. One of the strangest environments we encounter is the region surrounding massive stars near the end of their lives. These stars burn their nuclear fuel at extraordinary rates, shining with an intensity that can strip planets of their atmospheres from light years away. When such a star finally exhausts its core fuel, gravity wins in a catastrophic instant. The star collapses inward, then rebounds in a colossal explosion that can briefly outshine entire galaxies. The debris from this event races outward, enriching space with heavy elements, the raw materials from which planets, oceans, and even life itself are eventually formed. Destruction, in the universe, is often a prelude to creation. In the aftermath of these stellar deaths, reality grows even more extreme. Some collapsed stars leave behind neutron stars, objects so dense that their internal structure defies common sense. In these environments, electrons and protons are crushed together, forming matter unlike anything found on Earth. Gravity there is so powerful that it warps the very fabric of space around it. Time itself flows differently near such objects, slowing under the weight of intense gravity. To approach one would be to step into a region where everyday physics quietly breaks down. Even more unsettling are the regions where gravity overwhelms everything completely. Black holes represent the ultimate victory of gravity over all other forces. They are not cosmic vacuum cleaners roaming the universe, but they are places where space and time curve so steeply that escape becomes impossible once a certain boundary is crossed. From the outside, black holes can appear almost peaceful. Matter spirals inward, heating up and glowing brightly before vanishing from view. Beyond that boundary, known as the event horizon, our current understanding of physics can no longer describe what happens. Reality itself seems to end there, replaced by unanswered questions. Yet, black holes are not merely cosmic destroyers. They shape galaxies on the largest scales. At the centers of many galaxies lie supermassive black holes, millions or even billions of times more massive than the Sun. Their gravity influences the motion of stars across entire galactic cores. Paradoxically, these objects that swallow light may also regulate the growth of galaxies, controlling how gas collapses to form new stars. In this way, some of the most terrifying places in the universe also play a role in creating order on the grander scales. Far from galactic centers, space can appear deceptively calm, but even here, invisible forces dominate. Vast filaments of dark matter stretch across the universe, forming a cosmic web that guides the formation of galaxies and clusters. This dark matter does not emit light and cannot be seen directly, yet its gravitational influence is unmistakable. Galaxies rotate too quickly, clusters hold together too tightly, and gravitational lensing bends light in ways that demand the presence of unseen mass. We are surrounded by structures we cannot touch, see, or fully understand, yet they shape everything we observe. Between these filaments lie enormous voids, regions of space nearly empty of galaxies. These cosmic deserts can span hundreds of millions of light years. To travel through one would be to move through a realm of profound isolation, where the nearest galaxy might be unimaginably distant. These voids are not failures of the universe's design, they are an essential part of its structure, evidence that matter has been pulled into dense regions, leaving behind vast expanses of near nothingness. Even emptiness, on cosmic scales, has form and purpose. As we continue outward, we encounter galaxies unlike our own. Some are stretched into long, ghostly arcs by gravitational interactions. Others are locked in violent collisions, their stars flung into new orbits as clouds of gas ignite in furious bursts of star formation. In these galactic mergers, entire solar systems are rearranged over millions of years. From a human perspective, such events unfold slowly. From a cosmic perspective, they are sudden, transformative moments. What ties all these places together is not just their strangeness, but their indifference. The universe does not adjust itself for observers. It follows its own rules, driven by gravity, energy, and time on scales far beyond human experience. Yet, by studying these environments, we gain something remarkable. We gain perspective. Each extreme world reveals another way that matter and energy can organize themselves, another solution to the equations that govern reality. This journey through unreal places is not meant to make us feel small, though it often does. It is meant to remind us that our everyday experience represents only a narrow slice of what is possible. Beyond our planet, beyond our star, and beyond our galaxy, lies a universe filled with environments that challenge every assumption we carry. And still, we have only scratched the surface. As our journey carries us even farther, the universe begins to feel less like a collection of objects and more like a living structure, woven together by forces we can sense but not directly see. At these scales, distance itself becomes a defining feature of reality. Light, the fastest signal in existence, struggles to cross the immense gaps between cosmic landmarks. When we observe distant regions of space, we are not seeing them as they are now, but as they were long ago. The universe reveals itself as a layered archive of time, where looking outward is the same as looking backward. Among the most unreal places we encounter are the earliest visible structures in the cosmos. These ancient galaxies formed when the universe was young, dense, and radically different from what we experience today. They burned brightly with short-lived stars, flooding space with radiation that transformed surrounding matter. Many of these galaxies no longer exist in their original form. They merged, evolved, or were torn apart by gravity. Yet their faint light still reaches us, carrying information from an era when the universe was only beginning to take shape. To observe them is to witness cosmic history frozen into photons that have traveled for billions of years. Moving deeper still, we encounter regions where energy dominates over matter. Gamma-ray bursts are among the most powerful events known, releasing in seconds as much energy as the sun will emit over its entire lifetime. These bursts originate from the deaths of massive stars, or the mergers of dense stellar remnants. For a brief moment, they outshine nearly everything else in the observable universe. If one were to occur close enough to Earth, it could strip away atmospheres and disrupt ecosystems. Yet from a safe distance, they serve as beacons, illuminating the extreme physics of collapsing matter and intense magnetic fields. Beyond these explosive events lie environments shaped by constant, relentless radiation. Some regions near active galactic cores are bathed in energetic particles that would destroy biological molecules almost instantly. Here, matter is accelerated to near light speed, guided by magnetic fields twisted into colossal jets that extend far beyond their host galaxies. These jets carve paths through intergalactic space, heating gas and altering the evolution of surrounding structures. They are narrow, focused expressions of cosmic power, driven by processes that remain only partially understood. As we continue outward, the universe grows quieter in some ways, yet more unsettling in others. The background glow of the cosmos, the faint afterimage of the Big Bang itself, fills all of space. This radiation is nearly uniform, a whisper from a time when the universe was hot, dense, and opaque. It tells us that everything we see today emerged from a shared beginning. Every galaxy, star, and planet carries a connection to that initial moment, bound together by a common origin that transcends distance and time. In these vast expanses, we also encounter worlds that challenge our assumptions about life. Some planets orbit stars that flare violently, bombarding their surfaces with radiation. Others circle faint, long-lived stars, locked in eternal daylight on one side and endless night on the other. There are planets covered entirely by global oceans, with no continents at all, and worlds where the atmosphere itself rains molten rock. These environments stretch the definition of habitability, forcing us to reconsider what conditions might allow complexity to emerge. Speculation plays an unavoidable role here. On some distant planets, scientists imagine ecosystems unlike anything on Earth. Life might glow to survive perpetual darkness, or cling to heat sources beneath thick ice shells. These ideas are grounded in chemistry and physics, yet they feel almost mythical. They remind us that biology, like geology and astronomy, is shaped by environment. Change the conditions, and entirely new solutions may arise. At the largest scales, the universe reveals a geometry that feels abstract and unreal. Space itself is expanding, carrying galaxies away from one another as time progresses. This expansion is not like an explosion from a central point. It happens everywhere at once. The farther a galaxy is from us, the faster it appears to recede. Beyond a certain distance, galaxies move away so quickly that their light will never reach us. Entire regions of the universe are already beyond our cosmic horizon, permanently inaccessible. This realization introduces a profound limit. No matter how advanced our technology becomes, there are places we can never observe or influence. They exist, yet they are forever disconnected from us by the structure of space-time itself. The universe contains more than we can ever know, not because we lack intelligence or tools, but because reality imposes boundaries on information. And yet, within these limits, the universe continues to surprise us. Patterns emerge from chaos. Order arises from randomness. Laws that seem simple give rise to structures of staggering complexity. The same equations that govern falling apples also shape galaxies and bend light around massive objects. Across unimaginable distances and timescales, a consistent set of rules holds reality together. As we stand at this stage of our journey, surrounded by places that feel unreal, one idea becomes impossible to ignore. The universe is not just a backdrop for existence, it is an active participant, constantly evolving, experimenting, and transforming. Each extreme environment, each impossible-sounding location, is another expression of what the cosmos can become when given enough time and space. We are explorers, not because we travel physically to these places, but because we can imagine them, study them, and understand their role in the larger story. And still, there is more ahead. Even stranger regions await, where the nature of time, space, and reality itself grows ever more uncertain. As our exploration continues, the universe begins to confront us with ideas that feel less like places and more like challenges to reality itself. At these depths, the distinction between location, time, and physical law starts to blur. We are no longer simply moving through space. We are moving through the limits of understanding, where familiar concepts bend under the weight of extreme conditions. One such realm exists at the boundary between the observable universe and the unknowable beyond. Because the universe is expanding, there is a horizon to what we can ever see. Light from regions beyond this boundary has not had enough time to reach us since the beginning of cosmic history. These distant domains are not empty. They are filled with galaxies, stars, and perhaps worlds much like our own. Yet they are permanently cut off, separated from us, not by walls or distance alone, but by the flow of space-time itself. They exist, undeniably real, yet forever unreachable. Within the observable universe, time itself behaves in ways that defy intuition. Near extremely massive objects, time slows dramatically. A clock placed close to a dense gravitational source will tick more slowly than one far away. This is not an illusion or a trick of perception. It is a measurable effect, confirmed repeatedly by experiment and observation. In these regions, time becomes elastic, stretching and compressing, depending on gravity and motion. To travel through such an environment would be to experience reality at a different rhythm, where moments no longer align with those elsewhere in the universe. There are also places where motion alone reshapes reality. Objects moving at speeds close to that of light experience length contraction and time dilation. From their perspective, distances shrink and time slows around them. In extreme cosmic jets, particles are accelerated to such velocities, living brief existences shaped by relativistic effects. These environments are laboratories of pure physics, where the universe tests the limits of its own rules at every instant. At the smallest scales, the universe becomes even stranger. Space is not perfectly smooth. Quantum fluctuations ripple constantly through the vacuum, causing energy to appear and vanish in fleeting instants. These effects are normally invisible, drowned out by larger forces, but in certain cosmic conditions, they may leave detectable imprints, influencing the evolution of the universe itself. What appears to be empty space is, in reality, a restless sea of activity. Some of the most unreal places may not be locations in the traditional sense at all. They may exist as transitional states, moments when the universe shifts from one configuration to another. During its earliest instance, the cosmos underwent rapid expansion, smoothing and stretching space to enormous scales. Traces of this event may still be embedded in the distribution of galaxies and the background radiation that fills space. These traces are not landmarks you can point to. They are patterns written across the universe itself. As theory pushes further, scientists explore the possibility of regions where the fundamental constants of nature differ from those we measure locally. In such domains, chemistry might not work the same way. Atoms might be unstable, stars might never ignite, or matter might collapse almost instantly. These hypothetical places remain unconfirmed, but they arise naturally from attempts to understand the deepest laws of physics. They represent not just strange destinations, but alternate ways reality itself might organize. Even gravity, the most familiar of cosmic forces, may behave differently under extreme conditions. At the centers of black holes, our current theories predict singularities, points where density becomes infinite and known laws fail. Whether these singularities truly exist, or whether new physics intervenes, remains unknown. What is clear is that these regions mark the edge of our understanding, places where the universe forces us to admit what we do not yet know. Throughout this journey, one pattern repeats. The closer we look, the stranger things become. The universe does not simplify as we explore it. It grows richer, more complex, and more challenging. Each answer opens new questions. Each discovery reveals deeper layers of mystery. Far from being disappointing, this endless depth is what makes exploration meaningful. These unreal places remind us that human intuition evolved for survival on a small, calm planet orbiting an average star. It was never meant to grasp collapsing stars, expanding space, or time that flows at different speeds. Yet with careful observation, mathematics, and imagination, we have extended our understanding far beyond those limits. As we prepare to move onward, the lesson becomes clear. The universe is not strange because it is broken or chaotic. It is strange because it is vast, ancient, and governed by rules that operate far outside everyday experience. The unreal places we have explored are not exceptions. They are natural outcomes of cosmic law, playing out across scales of space and time that dwarf our own. And still, beyond these extremes, there are mysteries even deeper. Questions about the ultimate fate of the universe, the true nature of dark energy, and whether reality itself has boundaries or cycles. Our journey is far from over. In the next stage, we move toward the most profound questions of all, where the universe begins to reflect not just physical extremes, but existential ones as well. As we move toward the deepest questions the universe can pose, the idea of place begins to dissolve almost completely. What remains are conditions, boundaries, and possibilities rather than landscapes you could ever hope to visit. These are regions defined not by coordinates, but by limits, limits of temperature, density, energy, and even meaning. In this territory, physics and philosophy quietly begin to overlap. One such limit is the ultimate fate of the universe itself. Far in the future, long after stars like our sun have burned out, galaxies will drift farther apart, pulled by the steady expansion of space. Star formation will slow, then cease altogether. Existing stars will fade into remnants, white dwarfs, neutron stars, and black holes. Over unimaginable spans of time, even these remnants may decay or be swallowed by larger structures. The universe could approach a state of extreme cold and emptiness, where energy differences flatten out and meaningful change becomes rare. This scenario is not dramatic in the explosive sense. It is quiet, gradual, and profoundly unsettling. A universe that does not end in fire, but in silence. Another possibility is more abrupt. If the mysterious force driving cosmic expansion grows stronger with time, it could eventually overcome all other forces. Galaxies would be torn apart. Stars would be ripped from their orbits. Even atoms could be pulled apart as space itself stretches beyond their ability to hold together. In such a future, structure would not merely fade, it would be dismantled, piece by piece, by the expansion of reality itself. These scenarios are still uncertain, but they illustrate how the universe contains not just strange places, but strange endings. Even the beginning of the universe challenges our understanding of location and cause. The Big Bang was not an explosion at a point in space, it was an expansion of space itself, happening everywhere at once. There is no center to point toward, no edge to reach. Every region of space emerged from that initial state together. When we look out into the universe, we are not seeing debris thrown outward from a distant origin. We are seeing space unfolding over time. This makes the early universe one of the most unreal places imaginable. It existed everywhere, yet nowhere in the way we usually think about place. Some theories suggest that what we call the Big Bang may not have been the absolute beginning. It could have been a transition, a phase change from an earlier state of reality. In such models, our universe might be one chapter in a much larger story, possibly involving cycles of expansion and contraction, or the birth of multiple universes with different physical properties. These ideas remain speculative, but they arise from serious attempts to reconcile gravity with quantum mechanics. They represent the frontier where known physics strains under its own success. Within this speculative landscape, even time itself becomes questionable. In everyday life, time feels fundamental, always moving forward. Yet, some approaches to quantum gravity suggest that time may be an emergent property, arising from deeper, timeless laws. In such a view, the flow of time is not a basic ingredient of reality, but a consequence of how information and entropy evolve. If this is true, then the deepest level of the universe may not contain time at all. Change would exist without duration. Events would be related, but not ordered in the way we experience. There are also hints that space itself may be discrete at the smallest scales, composed of fundamental units rather than being infinitely divisible. If so, the smooth geometry we perceive would be an approximation, much like a photograph appears smooth from a distance but grainy up close. In these regimes, the idea of moving smoothly through space breaks down. Motion would be more like hopping between adjacent states, a concept that defies everyday intuition. Throughout all of this, a strange tension persists. The universe is governed by precise mathematical rules, yet the outcomes of those rules can appear wildly unpredictable. Quantum processes introduce genuine uncertainty, while chaotic systems amplify tiny differences into dramatic consequences. Together, these effects ensure that even in a law-driven universe, surprise is unavoidable. The unreal places we describe are not accidents. They are natural expressions of lawful behavior played out on extreme scales. What makes these regions especially compelling is that they are not disconnected from us. The atoms in your body were forged in ancient stars. The structure of your galaxy was shaped by dark matter and gravity over billions of years. The expansion of space affects even the light reaching your eyes. In subtle ways, the most extreme and unreal aspects of the universe are woven into the fabric of everyday existence. As our journey approaches its final stretch, one realization stands out above all others. The universe does not owe us familiarity. It does not conform to the shapes, timescales, or intuitions we find comfortable. Instead, it invites us to expand our thinking, to accept that reality is broader and stranger than our instincts suggest. Each unreal place we have encountered is a reminder that the cosmos is not constrained by human expectation. In exploring these environments, we are not just learning about distant stars or abstract theories. We are learning about the limits of understanding itself. Where knowledge ends, curiosity begins. And it is this curiosity that drives exploration forward, even when definitive answers remain out of reach. The universe, in all its strangeness, remains open to observation, to imagination, and to wonder. The places that do not seem real are real, and their existence challenges us to keep asking questions, even when those questions lead us far beyond familiar ground. At the furthest edge of our understanding, the universe begins to mirror the questions we ask about ourselves. The more extreme the environment, the more it forces us to confront not just physical limits, but conceptual ones. In these regions, reality feels less like a solid structure and more like an ongoing process, something continuously unfolding rather than something fixed. One of the most unsettling realizations is that the universe may have no final, stable state that resembles anything familiar. Even the long, quiet futures we imagine are only temporary phases. Over enough time, rare events become inevitable. Particles decay, orbits destabilize, structures that seem eternal slowly unravel. In this sense, the universe is never finished. It is always becoming something else, even when change is nearly imperceptible. There are also places defined not by what exists, but by what almost exists. Quantum theory allows for fluctuations so extreme that entire regions of space could briefly form exotic configurations before dissolving back into nothing. In some speculative models, tiny universes could momentarily appear and vanish, never growing large enough to leave a lasting trace. These are not destinations or landscapes. They are possibilities flickering at the edge of existence, reminders that reality may be far more restless than it appears. Cosmic inflation, the rapid expansion thought to have occurred at the universe's earliest moments, may not have happened just once. Some theories suggest it could still be happening in distant regions, continuously spawning new pocket universes. In this view, what we call the universe is only one bubble in a far larger structure. Other bubbles may obey different physical rules, with different constants, particles, and even dimensions. These regions would be forever inaccessible, separated from us by expanding space faster than any signal could travel. They would be real, yet permanently beyond contact. Such ideas are deeply controversial, not because they are fantastical, but because they challenge how science tests reality. If something exists but can never be observed, what does it mean to call it real? This question marks one of the most profound tensions in modern cosmology. It blurs the line between physics and philosophy, forcing scientists to reconsider the meaning of explanation itself. Even within our own universe, there may be dimensions beyond the familiar three of space and one of time. Some theories propose additional dimensions that are compact and hidden, curled up so tightly that they escape detection. If they exist, these dimensions could influence the behavior of particles and forces in subtle ways. Space, in this sense, would be richer than we perceive, layered with structure invisible to everyday experience. As we consider these possibilities, a pattern emerges. The universe does not place human beings at its center, either physically or conceptually. Our location in space is unremarkable. Our moment in cosmic history is brief. Yet we possess something rare, the ability to reflect on the universe and question its nature. In doing so, we transform distant, unreal places into objects of understanding. This act of understanding does not make the universe less strange. If anything, it reveals just how deep the strangeness runs. Each new insight opens wider horizons, exposing further mysteries rather than closing them. The unreal places we imagine today may become the studied realities of tomorrow, while new questions take their place at the frontier. In the end, the universe does not ask us to be comfortable with it. It asks us to be curious. It invites us to look beyond the familiar, to accept uncertainty, and to find meaning not in certainty, but in exploration. The places that do not seem real are not anomalies to be explained away. They are the natural outcome of a universe vast enough to contain every extreme. As this journey draws toward its conclusion, we are left not with final answers, but with perspective. We see that reality is broader than intuition, deeper than experience, and more flexible than imagination alone could predict. The universe is not limited to what feels real to us. It defines reality on its own terms. And in recognizing that, we take our place not as masters of the cosmos, but as witnesses, observers on a small world, orbiting an ordinary star, in a universe filled with places that challenge every definition we hold. The fact that we can even glimpse these unreal realms is a testament to the power of inquiry itself. The journey does not truly end here. It continues every time we look up, every time we ask another question, and every time we accept that the universe will always be stranger than we expect. As we reach the final stretch of this journey, the universe feels less like an external expanse and more like a mirror held up to our own existence. After traveling through unreal places shaped by gravity, time, and energy, one realization slowly settles in. The strangeness of the cosmos is not separate from us. It is the context from which we emerged. Every atom that forms your body was forged under conditions far more extreme than anything found on Earth today. Heavy elements were created in the hearts of massive stars and scattered across space by violent explosions. Over billions of years, gravity gathered that material into new stars, planets, and eventually into the chemistry that made life possible. In this sense, the most unreal places in the universe are not distant curiosities. They are ancestral environments. They are part of our own deep history. This perspective reshapes how we think about scale and meaning. Human lives are brief, civilizations are fragile, even planets have finite lifespans. Yet, the processes that gave rise to all of this operate across immense spans of time. The universe is patient in ways we are not. It builds complexity slowly, through countless iterations, allowing rare configurations to emerge and persist long enough to be noticed. Some of the most unreal places we have discussed exist precisely because the universe allows extremes to play out without restraint. Gravity is free to collapse matter until space and time bend beyond recognition. Energy is free to concentrate into flashes powerful enough to outshine galaxies. Expansion is free to stretch space itself, carrying regions of reality beyond mutual reach. There is no guiding hand moderating these outcomes. They are the natural consequences of simple laws applied over vast scales. And yet, from within this environment, awareness emerges. Conscious beings arise who can reflect on the universe that produced them. This fact alone adds another layer of strangeness to reality. The universe is not only capable of generating extreme physical conditions, it is capable of generating observers who can question those conditions and seek to understand them. In doing so, the universe becomes, in a sense, aware of itself. This does not require mysticism or purpose imposed from outside. It is an emergent outcome of complexity. Given enough time, matter organizes into structures that process information, adapt, and reflect. The same laws that govern collapsing stars also govern neural activity. The difference lies in scale and arrangement, not in fundamental principle. From this viewpoint, the unreal places of the universe are not separate chapters in a cosmic catalogue. They are interconnected parts of a single story. Black holes influence galaxy formation. Dark matter shapes cosmic structure. stellar explosions seed planets with the elements of life. Expansion sets the stage on which all of this unfolds. Remove any piece, and the universe we know would be profoundly different. There is also a quiet humility in recognizing how much remains unknown. For all our instruments and equations, vast portions of reality remain hidden or only partially understood. Dark energy, which drives cosmic expansion, dominates the universe's energy budget, yet its nature is still mysterious. The interiors of black holes remain beyond direct observation. The earliest moments of the universe are inferred indirectly, through subtle patterns imprinted on radiation and matter. These gaps in knowledge are not failures, they are invitations. They remind us that understanding is not a finished product, but a process. Each generation pushes a little farther, refining models, building better tools, and asking sharper questions. The unreal places of today often become the well-studied regions of tomorrow, only to reveal new layers of mystery beneath. As this journey concludes, we return mentally to where we began, a small planet orbiting an ordinary star in a galaxy among billions. Nothing about our location suggests importance, and yet, from here, we can trace the structure of the universe across vast distances and deep time. We can reconstruct events that occurred long before our planet existed. We can imagine futures that extend far beyond our own survival. The universe does not guarantee that it can be fully understood. It does not promise comfort or clarity. What it offers instead is depth, an endless hierarchy of scales, forces, and possibilities. The places that do not seem real are simply the regions where this depth becomes impossible to ignore. In acknowledging this, something subtle changes. The universe stops feeling like a cold, indifferent expanse and begins to feel like a complex, evolving system of which we are a temporary expression, not central, not privileged, but undeniably connected. The unreal places we have explored are reminders of how wide the spectrum of reality truly is. From frozen deserts and metallic oceans to collapsing stars and expanding space, the cosmos expresses itself in countless forms. Each one is real, each one follows the same underlying rules, and each one expands our understanding of what existence can be. The journey does not end with a final answer or a neat conclusion. It ends with awareness. Awareness that reality is larger than intuition, stranger than expectation, and richer than any single story can capture. And in that awareness lies the true value of exploration. Because every time we confront an unreal place in the universe, we are also confronting the limits of our own perspective. And each time we push beyond those limits, we take another small step toward understanding a cosmos that will always remain, in part, beautifully and profoundly unreal. When we pause after such a journey, something subtle but important happens. The universe no longer feels like a distant stage on which dramatic events unfold without consequence. It begins to feel like a continuous process that includes us, not as spectators standing outside, but as temporary patterns within it. The unreal places we have explored reshape how we understand reality, not because they are exotic, but because they reveal how flexible existence truly is. One of the most profound lessons comes from the realization that stability is the exception, not the rule. Stars are born, evolve, and die. Galaxies grow by consuming smaller neighbors. Even the large-scale structure of the universe changes over time. What appears permanent on human timescales is fleeting when viewed across cosmic history. The night sky feels timeless, yet every point of light represents a system in motion, slowly transforming according to physical law. There are places where this impermanence becomes impossible to ignore. In regions where stars are actively forming, clouds of gas collapse under gravity, fragmenting into dense cores that ignite nuclear fusion. These stellar nurseries are chaotic environments filled with turbulence, radiation, and shock waves. Out of disorder, structure emerges. Out of collapse, light is born. These places remind us that creation is not gentle. It is often violent, driven by instability rather than balance. In contrast, there are regions where change unfolds so slowly that it feels almost non-existent. Some stars burn steadily for trillions of years, far longer than the current age of the universe. Around them, planets may enjoy stable conditions across spans of time that dwarf human history. In these quiet corners of the cosmos, the universe experiments with patience, allowing complexity to persist and evolve gradually. These environments feel unreal not because they are extreme, but because they are so enduring. At the boundaries between order and chaos, the universe seems to test its own limits. Gravitational interactions can fling stars from galaxies, sending them drifting alone through intergalactic space. These orphan stars wander in darkness, separated from any stellar family, carrying their planets with them into eternal night. Such systems exist without a home, shaped by encounters that occurred millions or billions of years earlier. They are reminders that cosmic history leaves lasting consequences. The more we explore, the more we see that chance plays a crucial role alongside law. The universe follows strict rules, yet small variations in initial conditions can lead to dramatically different outcomes. A slight difference in density can determine whether a region becomes a galaxy or a void. A minor shift in orbit can mean the difference between a stable planet and a catastrophic collision. These sensitivities give rise to a universe that is lawful, yet endlessly diverse. This diversity extends beyond physical environments into the realm of possibility. The same physical constants that allow stars and chemistry to exist also permit a vast range of planetary conditions. Some worlds are locked in perpetual storms. Others are frozen into stillness. Some may experience cycles of extreme change, while others remain stable for eons. The universe does not settle on a single solution. It explores many at once. From this perspective, unreal places are not rare exceptions scattered across space. They are the natural outcome of a universe that allows variation to flourish. Given enough space and time, every permissible configuration will appear somewhere. What feels impossible locally becomes inevitable globally. The cosmos is large enough to make improbability routine. This realization reframes how we think about our own environment. Earth feels finely balanced, almost miraculous in its ability to support life. Yet it is one expression among countless experiments carried out by the universe. Its conditions are not imposed by intention, but selected by survival. Life persists where it can, shaped by whatever environment happens to exist. In this sense, habitability is not a goal the universe aims for. It is a consequence of diversity and time. As observers, we occupy a unique position. We are products of cosmic processes, yet capable of reflecting on them. This reflection does not grant us special status in the physical sense, but it does grant meaning, meaning not imposed from outside, but constructed through understanding. By studying unreal places, we expand the boundaries of what we consider real, and in doing so, we expand our sense of belonging within the cosmos. There is also a quiet comfort hidden within this vastness. The same laws that create black holes and cosmic voids also ensure consistency. The universe is strange, but it is not arbitrary. Patterns repeat across scales. Atoms resemble miniature solar systems in structure, governed by different forces but similar principles. Spiral galaxies echo the forms of hurricanes and shells. Complexity arises again and again, shaped by simple rules applied repeatedly. In this way, the unreal becomes familiar. The more we learn about extreme environments, the less alien they feel. They remain awe-inspiring, but they also become understandable. This transformation from mystery to comprehension is one of humanity's greatest achievements. It allows us to stand in a universe that is indifferent to us, yet still feel connected to it through knowledge. As our exploration continues beyond this point, the distinction between science and story begins to blur. Facts alone cannot capture the full impact of a universe this vast. We rely on narrative, metaphor, and imagination to bridge the gap between equations and experience. These tools do not diminish truth. They make it accessible, allowing us to grasp ideas that would otherwise remain abstract. The unreal places of the universe serve as anchors for this understanding. They give form to concepts that would otherwise remain invisible. Through them, we encounter time that stretches and compresses, space that expands and curves, and matter that behaves in unfamiliar ways. Each encounter refines our intuition, slowly aligning it with reality rather than comfort. And so, the journey continues not toward a destination, but toward deeper awareness. Awareness that reality is not obligated to match human expectation. Awareness that understanding is always provisional. Awareness that the universe is both knowable and inexhaustible. In embracing this, we accept our role not as conquerors of the cosmos, but as interpreters. We translate the language of the universe into meaning, knowing that translation is never complete. There will always be nuances beyond reach, places beyond observation, and questions without final answers. Yet it is precisely this incompleteness that keeps exploration alive. The unreal places of the universe are not there to be exhausted. They are there to remind us that existence is larger than any single explanation. And in that reminder, curiosity finds endless room to grow. At this stage of the journey, the universe feels less like a collection of destinations and more like a continuous unfolding of relationships. Everything we have explored, from violent stellar deaths to silent cosmic voids, is connected by underlying principles that repeat across scale and time. The unreal places do not stand apart. They emerge naturally from the same rules that govern the familiar world, revealing how far those rules can be stretched before intuition finally gives way. One of the most striking realizations is that complexity does not require intention. The universe does not plan. It does not anticipate outcomes. Yet, from simple beginnings, it produces structures of astonishing intricacy. Galaxies form delicate spirals. Planetary systems settle into resonant patterns. Even chaos follows statistical regularities. This suggests that order is not imposed from above, but arises from interaction. Given enough time, matter explores every allowed configuration, and some of those configurations persist long enough to become meaningful. In certain regions of the universe, this process leads to environments that seem almost contradictory. There are places where matter is packed so densely that individual particles lose their identity, merging into collective states governed by quantum rules. Elsewhere, matter is so sparse that atoms may drift for ages without encountering another particle. Both extremes are real. Both follow the same fundamental laws. The difference lies only in initial conditions and scale. These extremes challenge how we define existence itself. In everyday experience, reality feels solid and continuous. But in the universe at large, solidity is rare. Most of space is empty, and even what we call solid matter is mostly void at the atomic level. The unreal places of the cosmos make this explicit. They show us that what feels substantial is often a fragile balance of forces, easily disrupted under different conditions. Time, too, reveals its flexibility. We experience it as a steady flow, one moment following another. Yet, across the universe, time stretches, slows, and even appears to fracture depending on gravity and motion. In some regions, processes unfold so rapidly that entire stellar life cycles play out while distant observers barely notice change. In others, time drags so slowly that evolution seems frozen. The universe contains every tempo at once, layered across space. As we approach the conceptual horizon of our understanding, the question of meaning inevitably arises. Does a universe this vast and indifferent contain purpose? From a physical perspective, the answer is neutral. The universe follows laws, not goals. Yet meaning does not require cosmic intention. It arises from relationship and context. For beings capable of reflection, meaning is constructed through connection, understanding, and experience. In this sense, the unreal places of the universe acquire significance precisely because we can know about them. They expand our sense of what exists and, by extension, what we are part of. Each discovery reshapes our internal map of reality, altering how we place ourselves within it. The universe does not grant importance, but it allows for awareness. That allowance may be one of its most remarkable features. There are also ethical implications hidden within this perspective. Recognizing the fragility of structure on cosmic scales can foster humility. Civilizations rise and fall, planets change, stars die. Against this backdrop, the preservation of knowledge, culture, and life takes on a different weight. Understanding how rare certain conditions are does not diminish their value, it enhances it. As exploration continues, technology extends our senses farther into space and deeper into time. Instruments detect signals so faint they border on nothingness. Computers simulate environments we can never visit. Mathematics allows us to describe realities that no experiment can yet test directly. These tools do not remove mystery, they sharpen it, outlining the boundaries between what is known and what remains speculative. Some of the most unreal places may forever remain theoretical, yet theory itself is not fantasy. It is disciplined imagination, constrained by evidence and logic. When theory succeeds, it predicts phenomena later confirmed by observation. Many of today's established ideas once seemed absurd. The history of science is a record of intuition repeatedly corrected by reality. This pattern suggests that the universe will continue to surprise us. Concepts that feel impossible now may become routine explanations in the future. New mysteries will replace old ones, not because progress stalls, but because understanding deepens. The unreal places we contemplate today are milestones in that process, markers of how far curiosity has already carried us. As this part of the journey unfolds, one truth stands out. The universe is not static knowledge waiting to be collected. It is an evolving relationship between observation and explanation. Each answer changes the questions we ask next. Each insight alters the landscape of what feels real. In acknowledging this, we arrive at a quieter form of wonder, not the shock of spectacle, but the steady appreciation of coherence. The same principles that govern distant galaxies also govern the atoms in your body. The same mathematics describes collapsing stars and rippling water. Reality is unified not by simplicity, but by consistency across unimaginable scales. The unreal places of the universe are, in the end, reminders of that unity. They show us how far reality extends beyond familiar ground, while still remaining governed by the same underlying order. To explore them is not to escape reality, but to encounter it more fully. As we prepare to move toward the final reflections of this journey, the emphasis shifts once more, from external exploration to internal integration, from cataloging extremes to understanding what those extremes reveal about existence itself. The universe remains vast and strange, but it is no longer distant. It becomes a context we inhabit, a story we are embedded within, whether we choose to notice it or not. And in that awareness, the unreal becomes not something to fear or dismiss, but something to learn from. A reminder that reality is richer than habit, deeper than assumption, and always capable of surprising those willing to look beyond the familiar. As the journey reaches its closing movement, the universe no longer feels like a series of distant extremes. Instead, it resolves into a single, immense continuum where the unreal and the familiar are simply different expressions of the same underlying reality. What once seemed alien now feels inevitable. Given enough space and enough time, the universe explores every possibility allowed by its laws, and in doing so, it reveals the full range of what existence can be. One of the most striking insights from this exploration is how deeply interconnected everything is. Events separated by billions of light years can influence one another through gravity and expansion. Processes that occurred near the beginning of cosmic history still shape what we observe today. The distribution of galaxies, the temperature of background radiation, and even the availability of elements necessary for life all trace back to conditions set long before stars, like our sun, were born. The unreal places of the universe are not isolated curiosities. They are chapters in a single, unfolding narrative. This narrative has no author and no intended ending. It is written by interaction. Matter responds to gravity. Energy follows gradients. Space expands. Time progresses according to physical law. Out of these simple ingredients, complexity arises naturally, not because it must, but because it can. The universe does not optimize for beauty or meaning, yet both emerge as byproducts of structure and scale. At this point, the distinction between observer and observed becomes increasingly subtle. We study the universe using tools made of the same particles we observe. Our theories are encoded in matter shaped by stellar processes. Even our thoughts are physical events unfolding within neural systems governed by chemistry and electricity. In a very real sense, the universe is examining itself through us. This does not elevate humanity above the cosmos. It situates us firmly within it. The unreal places we have encountered highlight how narrow everyday experience truly is. Our senses evolved to navigate a small range of temperatures, pressures, and energies. Outside that range, intuition fails. Yet reality does not change to accommodate perception. Black holes remain real even if they defy visualization. Expanding space continues whether or not it aligns with common sense. Time bends regardless of how steady it feels to us. Understanding this can be both humbling and liberating. It frees us from the assumption that reality must conform to comfort. It allows us to accept mystery without frustration. Not knowing everything is not a flaw in understanding. It is a natural consequence of being finite observers in an infinite or near infinite system. There is also a quiet resilience embedded in this view. The universe has endured extremes far beyond anything life on Earth has faced. It has survived violent transitions, collapses, and expansions. From those upheavals, new structures emerged. This suggests that change, even when destructive, is rarely absolute. It is transformative rather than terminal. The cosmos does not reset to nothing. It reorganizes. As we reflect on the unreal places that populate the universe, we begin to see them less as anomalies and more as teachers. Each extreme environment demonstrates a principle in its purest form. Black holes reveal the power of gravity. Neutron stars expose the limits of matter. Cosmic voids illustrate the consequences of expansion. Distant galaxies show how time and light intertwine. Together, they form a curriculum written across space itself. What we take from this curriculum depends on perspective. For some, it inspires awe. For others, insignificance. For many, it sparks curiosity that refuses to settle. The universe does not dictate the emotional response. It presents the facts. Meaning arises in how those facts are integrated into understanding. As this exploration draws toward its final reflection, one idea remains constant. Reality is larger than intuition, but not inaccessible. Step by step, observation by observation, the unreal becomes comprehensible. Not fully tamed, not completely mapped, but increasingly familiar. The boundary between known and unknown shifts outward, carrying mystery with it rather than eliminating it. This is the enduring rhythm of exploration. Each generation inherits a universe that feels vast and strange, pushes back its boundaries, and hands the remaining questions forward. The unreal places of today become the foundations of tomorrow's knowledge, even as new unreal places take their place at the frontier. In the end, the journey through places that do not seem real leads to a surprisingly grounded conclusion. Reality does not need to feel familiar to be meaningful. It does not need to be gentle to be coherent. The universe is not designed to reassure us. It is designed, in the most neutral sense, to exist. And within that existence, awareness arises briefly, asking questions, telling stories, and seeking patterns. That awareness is fragile, temporary, and profoundly rare. Yet it is enough to bridge the gap between a universe that is indifferent and a universe that is understood. The unreal places we have explored are not distant dreams. They are. As the journey reaches its final horizon, the universe settles into a quieter kind of clarity. Not clarity in the sense of complete understanding, but clarity of relationship. After moving through places shaped by extremes of gravity, time, energy, and scale, what remains is a simple realization. Reality does not need to be fully grasped to be deeply felt. The unreal places of the cosmos teach this lesson repeatedly, not through explanation alone, but through perspective. From the smallest quantum fluctuations to the largest structures of galaxies and voids, the universe reveals itself as a continuous experiment. Nothing is static, nothing is truly isolated. Even the most distant regions are linked through shared origins and common laws. What changes is not the foundation, but the expression. The same principles manifest as gentle starlight in one context and as catastrophic collapse in another. The difference is scale, not essence. In this light, the distinction between ordinary and extraordinary begins to blur. A quiet sunrise on a small planet and the birth of a star in a distant nebula are separated by magnitude, yet governed by the same cosmic logic. Fusion, gravity, and energy flow operate everywhere, indifferent to whether their outcomes are witnessed or ignored. The universe does not elevate spectacle above subtlety. Both are equally real. This understanding reshapes how unreal places are perceived. They are not violations of reality, but confirmations of its range. They show us what happens when familiar rules are pushed beyond everyday boundaries. They remind us that intuition is not a guide to truth, but a local adaptation. When intuition fails, it does not signal error in the universe. It signals the need for new ways of thinking. There is a quiet elegance in this. The universe does not conceal itself out of malice. It reveals itself gradually, allowing understanding to grow alongside curiosity. Each generation inherits a partial picture and adds detail, depth, and nuance. What once seemed impossible becomes accepted. What once seemed unknowable becomes approachable. And yet, mystery never disappears. It simply relocates to the edges. At those edges, humility becomes essential. The universe is not arranged around human questions. It does not promise relevance or comfort. It simply unfolds according to its nature. Yet within that unfolding, moments of insight emerge. Patterns repeat. Laws remain consistent. Meaning becomes something discovered through engagement rather than delivered as a gift. This perspective changes the role of exploration. To explore is not to conquer or control, but to listen. It is to pay attention to how reality behaves when pushed to its limits. The unreal places of the universe are not trophies of knowledge. They are teachers of restraint, reminding us that understanding has boundaries and that those boundaries are valuable. There is also a subtle reassurance hidden within this vastness. Although the universe is indifferent, it is not hostile. It allows complexity to arise and persist. It allows fragile structures to endure for long enough to matter. It allows awareness to flicker into existence, however briefly, and to reflect on its surroundings. These allowances are not guarantees. They are opportunities. Within those opportunities, stories form. Not stories imposed on the universe, but stories drawn from it. Narratives help bridge the gap between abstract law and lived experience. They do not replace science. They complement it, giving shape to ideas that would otherwise remain distant. Through story, the unreal becomes relatable without losing its integrity. As this journey concludes, the unreal places of the cosmos no longer feel like distant curiosities. They feel like extensions of a shared reality, expressions of a universe that is vast enough to contain contradiction without collapse. A universe where stability and chaos coexist, where creation and destruction are intertwined, and where meaning emerges locally rather than universally. The final lesson is not about scale or power, it is about context. We exist within a universe that does not center us, yet includes us completely. Our atoms were forged in extreme environments. Our planet formed through chaotic processes. Our awareness emerged from complex chemistry shaped by cosmic history. There is no separation between the unreal and the real, only gradients of familiarity. In recognizing this, something profound occurs. The universe becomes less alien without becoming less strange. Its extremes remain extreme. Its mysteries remain unresolved, but our relationship to them changes. Curiosity replaces intimidation. Wonder replaces confusion. The unreal becomes an invitation rather than a barrier. The journey through these places ends where it began, not in distant space, but in perspective. We look outward to understand inward. We study the cosmos to learn what kind of reality allows observers to exist at all. The answers are partial, evolving, and incomplete, yet they are enough to sustain exploration. The universe does not ask us to solve it. It asks us to engage with it, to observe carefully, to think patiently, to accept uncertainty without surrendering curiosity. In doing so, we participate in a process far larger than ourselves, a process that has been unfolding since the earliest moments of cosmic history. The unreal places of the universe remain unreal only until they are understood, and even then, they retain a residue of mystery, a reminder that reality is always deeper than description. That depth is not a flaw, it is the source of wonder. With that understanding, the journey reaches its quiet conclusion, not with certainty, but with openness, not with final answers, but with enduring questions. The universe remains vast, strange, and unresolved, and that is precisely why it continues to matter. Because as long as there are unreal places left to imagine, there will be minds willing to explore them, expressions of the same reality that allows you to sit, listen, and reflect. In recognizing that connection, the cosmos becomes not smaller, but closer, vast, strange, and ultimately shared. And with that realization, the journey finds its quiet resolution, not in answers, but in perspective, not in certainty, but in acceptance. The universe remains unreal in many ways, and that is precisely what makes it endlessly worth exploring. At the very end of this journey, when words begin to run out and explanation reaches its natural limit, the universe offers one last perspective. After traveling through places that bend matter, stretch time, and dissolve intuition, what remains is not a map of locations, but a deeper understanding of reality itself. The unreal places of the universe were never meant to feel comfortable. They exist to remind us that existence is broader than habit and deeper than instinct. What becomes clear is that reality does not sit still. It is not a finished structure waiting to be catalogued. It is an ongoing process, unfolding across scales so vast that human life occupies only a fleeting moment within it. Stars ignite and fade, galaxies assemble and disperse, space expands, carrying regions forever beyond contact. None of this happens for an audience. It happens because the laws of nature allow it, and because time is generous enough to let consequences play out fully. In this sense, the universe is not strange because it violates logic. It is strange because logic, when applied over immense scales of space and time, produces outcomes far removed from everyday experience. Gravity, when given enough mass, collapses stars into objects that warp reality. Energy, when concentrated, reshapes matter in explosive flashes. Expansion, when sustained, redraws the boundaries of the observable world. The unreal is simply the familiar taken to its natural extremes. There is also a subtle emotional shift that accompanies this realization. Early in the journey, the unreal places may have felt intimidating or alien. They challenged comfort and intuition, but by the end, they feel oddly consistent. The same rules apply everywhere. There are no hidden exceptions. Reality is not fragmented into separate domains of sense and nonsense. It is unified, even when its consequences feel overwhelming. This unity reshapes how we think about meaning. Meaning does not arrive from the cosmos as a message or instruction. It arises locally, within awareness. It emerges when patterns are recognized, when relationships are understood, and when context is grasped. The universe does not tell us why it exists. It shows us how it exists. From that understanding, meaning is constructed rather than discovered. The unreal places of the universe play a crucial role in this process. They stretch understanding until it breaks free from narrow assumptions. They force imagination to align with evidence rather than comfort. In doing so, they expand what feels possible. They train the mind to accept that reality is not obligated to match intuition, only to follow its own rules. There is humility in this lesson. Humanity occupies no central position in space or time. Our planet is not special by location, and our era is not privileged by duration. Yet within this unremarkable position, awareness arises, questions form, curiosity persists. This combination is rare not because the universe forbids it, but because it requires a delicate balance of conditions that may not occur often. That rarity does not imply cosmic importance. It implies responsibility. To understand the universe, even partially, is to recognize how fragile knowledge can be and how easily it can be lost. Civilizations come and go, records fade, yet the universe continues, indifferent to memory. What endures is not awareness itself, but the conditions that allow it to arise again elsewhere, given enough time. As the journey closes, the unreal places we have explored no longer feel like distant spectacles. They feel like boundary markers, showing where intuition fails and understanding must evolve. They reveal that reality is not designed to be easily grasped, but it is structured enough to be explored. This balance between mystery and order is what makes science possible and what keeps curiosity alive. There is also comfort hidden in this vastness, not the comfort of certainty, but the comfort of consistency. The universe does not change its rules arbitrarily. What holds true here holds true elsewhere. The same principles that govern distant galaxies govern the atoms in your body. You are not separate from the cosmos. You are one of its expressions, temporary and fragile, yet entirely real. In recognizing this, the boundary between observer and observed softens. The universe is not something happening elsewhere while life watches from the sidelines. Life is one of the ways the universe processes itself. Through observation, measurement, and reflection, the cosmos becomes partially self-aware, not in intention, but in consequence. The unreal places of the universe, then, are not merely destinations for imagination. They are reminders of scale, reminders of patience, reminders that existence does not revolve around familiarity. They teach that reality is richer than expectation, deeper than explanation, and always capable of exceeding the frameworks built to contain it. When the journey finally ends, it does so quietly. There is no final revelation, no closing answer that resolves every question. Instead, there is a shift in perspective. The universe feels larger, but also closer, stranger, but also more coherent, less personal, yet more connected. This is the paradox at the heart of exploration. The more we learn, the more we realize how much remains unknown. Yet that unknown is no longer frightening. It becomes an open horizon, inviting further inquiry rather than demanding resolution. The unreal places of the universe remain, scattered across space and time, waiting not to be conquered, but to be understood. And as long as there are minds capable of wonder, the journey will continue. Not toward an ending, but toward deeper awareness of a reality that will always be bigger than any story told about it. In that awareness, the universe does not become smaller or simpler. It becomes honest, vast, indifferent, lawful, and endlessly surprising. And within that honesty lies its greatest gift. Not answers, but the freedom to keep asking. This is where the journey truly ends. Not in space, not in time, but in perspective. The unreal is real. Reality is vast, and understanding is always a work in progress.